Hey, what's up? John Sonmez from simpleprogrammer.com. And I am here again with another interview. I know that a lot of you have really been digging the interviews that I've been doing here. And I have another extremely high profile person here that I'm really excited to interview. His name is Perry Marshall. And Perry, if you don't know him, he is he's a pretty famous copywriter and internet marketer. But aside from that, if you haven't seen already, I did this video where I reviewed his book called Evolution 2.0, and that's what we're going to really talk about today is that book and really the ideas and just some of the thinking, right? That using your brain, actually not just believing what other people tell you, and actually discovering things for yourself. So anyway, I without further ado, I just want to welcome you, Perry, and thanks for doing this.
Well, John, thanks for having me on your show. And I appreciate all of the coders and programmers out there that you guys all make the 21st century possible. And I've hired quite a few coders and programmers myself. And, what you guys do is indispensable. And I think you're also going to find that y'all know a lot more about evolution than you probably think that you do. You just never really thought to move that thinking over to other departments like biology. So we're going to have a lot of fun today talking about that.
Yeah. Just to give you some background, Perry, on what I did this video, this first video on, like, someone asked me a question like, "Are you a creationist or an evolutionist?" And my video response was sort of like, "Well, I've been on both sides of the equation. There's decent arguments on both sides of the equation, and I'm not 100% sure. I don't need to know necessarily the answer." And people lost their minds. They were like, "Oh, how could you call yourself an engineer or be a programmer without believing, like, this is this fundamental views of evolution that have been taught by Darwinian evolution?" And I was thinking, man, I'm trying to tell people to use their brains.
Yeah.
So I was really excited when I read your book. Josh Earl, a mutual friend and business partner here at Simple Programmer, he recommended. He said, you got to read Perry's book. You got to read it. It's really good. It approaches it from a totally different perspective. It's something that you're gonna agree with. And I read it, or actually listened to the audio version, and I was blown away. I was like, wow, this is what I would just want people to, like, think about things this way.
Well, this is one of the most contentious topics. Okay. I mean, it is right up there with things like gun control, gay rights, abortion. Like,
Yeah.
literally, it's that primal. People respond that emotionally. And it's pretty hard to get people to relax and actually just think about it. And that's what I had to do when I got sucked into this topic about a dozen years ago. Was, okay, hang on a second, set your prejudices aside, set your preconceived notions aside, understand that the world may not work the way that you think that it does, but you follow the evidence, follow the evidence, follow the evidence, and you have to have a high standard of what counts for evidence. Okay.
Right.
And now what you'll find is that most people default to whatever they consider to be an authority. So if you grew up in a fundamentalist church and your authority is a certain preacher, you're going to probably default to that. If you had a certain educational background and certain kinds of scientists tell you, no, it's like this, then you'll probably default to that. And I said, well, what I'm going to do is I'm going to have a few rules for my search. I am not going to ignore any verifiable fact.
Right.
If I can verify, if I can, like, lay my hands on it or show that, oh yeah, like a dozen people have done this experiment over and over and it produced this kind of result, I will not go in denial. In fact, I'm willing to put a whole bunch of things on my wall of Post-it notes, if you will. I'm willing to put a whole bunch of things, as long as they're verifiable fact. I'll put them up on the board, even if I can't figure out they fit together today,
Right.
right? Maybe I'll figure it out next week. Maybe I'll see how the puzzle fits together next year. But if it's a verifiable fact, I'm not going to ignore it. I'm not going to deny it. And so that's what I did, and it got so fascinating. But first, I had to slice through a lot of dogma, a lot of indignation, like righteous indignation.
Right.
It came from both sides. How dare you? How dare you defy these authorities? And I started seeing that not everybody, but the certain strand of scientists was really being treated like high priests rather than, and if now I got to be clear about something. I am an electrical engineer, and I understand certain parts of science very, very, very well. Okay. And there's
Right.
a certain confidence that you gain when you experimentally, because you build things for a living, because you design things for a living, because you have a hard ass job with rigorous requirements. When you design something, and if it has product flaws, those warranty returns are going to come and bite you in the ass. You get this really keen appreciation for reality, right? And I used to sit in meetings and argue for hours about theoretical models of this and that and all this kind of stuff. I remember when I was an engineer at Jensen, I was an acoustical engineer. I designed the speakers of the 94 Ford Probe, the 95 AccuVigor, the 95 the 96 Honda Civic, the 96 Dodge Stratus, and 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 companies would send people to give us presentations, and we would call them lunch and learns, and somebody would buy pizza and we'd all sit in there, and before the guy showed up, everybody would always ask, all right, so is this an engineer or is this a marketing guy? And if it was a marketing guy, we knew that we couldn't like be totally rude and rip him to shreds, because we knew we were going to ask him a bunch of questions and he wasn't going to know the answer, and then he was going to have to go back to somebody, and so we would just have to go play softball. But what people really wanted when we had those lunches was somebody we could play hardball with. We could ask him really hard questions and push him to the wall. And so in my profession today, I'm a marketer, and what I really am is I'm in the business of scientific advertising,
Right.
which that's the title of a book written in 1918, which laid the foundations for direct response marketing, which is a highly scientific approach to marketing. And if you don't believe me, just pick up a book on Google Analytics or Google AdWords and see if that's the case. But we're not actually having a marketing conversation today. We're having an engineering conversation. We're talking about evolution as an engineered process. And we're talking about what can you actually find out, figure out, see, know, and discover about evolution when you put on your engineering hat. And like I said at the beginning of this conversation, John, if you're a programmer, if you're an engineer, if you build things for a living, you know a whole lot more about evolution than you even think you do.
Right. Yeah. Okay, yeah, and I think that's important to frame the discussion too, because I think a lot of people they get this knee-jerk reaction. I mean, some people are watching this now and they're just ready. They're already ready to attack and jump.
Yeah.
And it's like, we're not going to, and I think it's important just to let the cat out of the bag a little bit. What you've proposed in the book is not saying that evolution doesn't have. It's not a creationist view of the world, a literal 7-day creation view of the world. It is looking at, like you said, evidence and saying, what evidence do we actually have from and I like it that you gave that background from an engineering perspective, as opposed to this is what I've heard perspective, which is not verifiable facts. So what is, I guess, the core of the whole thing is what is different about your approach and what you say and what you found about evolution that makes it evolution 2.0 versus the traditional Darwinian evolution viewpoint?
Well, when Bill Gates started Microsoft, he was a total outsider in the computer industry. And
Mm.
when Fred Smith started Federal Express, he was a total outsider in the shipping industry. And when Jeff Bezos started Amazon, he was a total outsider in the book industry. And there's a long list of stories like this. Larry and Sergey, who started Google, they were total outsiders in the search engine industry. In fact, they started with a PhD thesis about how to rank scientific papers, and it turned into so far the world's best algorithm for internet search results. And so innovations almost always come from outsiders. Ray Kroc, when he started McDonald's, he was an outsider to the restaurant business. He was a milkshake salesman. And so I actually come as an outsider, but I come with a very rigorous scientific background. So the story starts in 2004. I'm visiting my brother, who at the time was actually a missionary in China, who had gone in 4 years. He had gone from seminary grad, I'm going to go save the world, to I'm not sure I believe any of this anymore. In fact, I'm sure that I don't believe most of it, and I'm not sure if I believe any of it. We had already been having this argument for a couple years, so there was already a long history. And as I was sliding to the edge, I found myself grabbing onto the one thing that I knew, which was science.
Right.
And again, when you've been through 5 years of engineering school, and then you've worked in the profession for a number of years, you know certain things. And I said to Brian, Brian, look at the hand at the end of your arm. I said, this is a really nice piece of engineering. And nobody ever disagrees with that, right? Nobody. And I said, you don't think this is a result of a accumulation of random accidents, do you? And he goes, hold on. And then he starts with a standard neo-Darwinism formula. Now, I listened to him and I said, okay, I don't really buy what he's saying. That does not make sense to me, because I've never seen anything designed like that. I've never seen any product get developed that way. But I know that most biologists would agree with him and not me. And I know biologists are not stupid. And I know they know a lot of things that probably defy common sense. There's a lot of things in electrical engineering that defy common sense. And you know what I immediately thought of? I'm sure some people listening will know what I'm talking about. In math, there's this thing called imaginary numbers, and you have the square root of -1. Well, guess what? In signal processing, those square roots of -1 are, and those imaginary numbers are extremely useful.
Yeah.
And I'll just tell you, like, they are. I'm an audio engineer. They're used in audio all the time. I would have never ever figured out by myself how to use that. In fact, there's a bunch of things in audio I would have never figured out without just going to school and learning them. Totally counterintuitive. So if somebody said to me, but actually, Perry, random mutation and natural selection can produce evolution, you just don't happen to think so because you don't know certain things, I was totally willing to believe that. I'm like, hey, I'm not a biologist. They might know something I don't know, but I'm going to find out. Either there's something the engineers know that the biologists don't know, or there's something the biologists know that the engineers don't know. Whatever it is, it's got to be pretty interesting. I'm going down the rabbit hole and I'm going to find out. And you know what? If this makes me an atheist, if this makes me a Buddhist, if whatever, okay, I don't know where this is going, but I'm going to follow it. Because I know that in science, you can stick things in a lab and you can do certain things. And if you can create an experimental result, then you know something you didn't know before. So I went down the rabbit hole. And I just decided I'm going to chase this thing wherever. So I go down the rabbit hole. So I obsessively, and I'm sure you can relate to this because like anybody that does podcasts, your brain is like an octopus and it goes in all these directions. And, you got all these books and all these things you're into, so I start buying books. I mean, like, I'm sure Amazon stock must have gone up,
Yeah.
and I'm buying books and I'm going to websites and like, I'm reading everything. Like, there isn't anything that's off limits. And I just floundered around for quite a while, honestly. And it was like, for a long time, I felt like, well, do I believe these guys or do I believe those guys? They both actually make a certain amount of sense at certain points along the way. But like, how do I decide when they disagree with each other? It's like, I have to get deeper than this. I have to get to something that I can personally verify. And finally one day it was like, bam, it was this giant epiphany. It was like 1,000 connections in 10 seconds inside my brain. I was trying to understand DNA, genetic code, mutations. How does this work? How do mutations make evolution? And I suddenly have this, it's like this flash of recognition. I'm like, hey, wait a minute. This is a code. This is digital code. Code, CODE. Like, your audience, John, are coders.
Right.
They
Exactly.
write code for a living. Hey, wait a minute. Okay, so I wrote a book called Industrial Ethernet in 2002. And I wrote it for the world's largest professional society of process control engineers. It's called the ISA. They have a magazine, they have conferences, they have a professional association, all this kind of stuff. And I wrote an Ethernet book for them because for years I specialized in digital communications. I sold digital networks that go in factories where the downtime is $15,000 a minute. And like, if something goes wrong, people are really, really upset. And I was in the job of helping people design these systems and use networks instead of point-to-point wiring. And like, the whole world was getting wired. The whole world was hooking up to networks. And so I wrote this Ethernet book. Like, hey, wait a minute. Almost everything in genetics has a parallel in Ethernet.
Right.
Okay? There's start bits. There's stop bits. There's packets. There's encoding tables, there's decoding tables, there's error correction, there's redundancy, there are checksums. Oh my goodness.
Yeah.
Wow. Now, like, this connection, like, it took about 10 seconds for all of a sudden the light bulb to go on. And then I literally spent the next 10 years tracking down, okay, so how many of these things are like, one thing is exactly like the other, and how many of them, no, it's not really like the other? Well, they're kind of like about 50% the same, especially at the most basic level, that DNA is a digital storage mechanism. It has about the same amount of storage in a human body. Human DNA has about the same amount of storage as a CD-ROM. It's about 750 megabytes of data. Okay. And all of a sudden, it's like, I can figure this out. Evolution can be studied as a software engineering problem. And if somebody says that one organism is like this, and eventually it could be like this, we can sequence the DNA, we can see what happened, we can figure it out. And,
Right.
and this, it's all digital code. So like I said, if you write code for a living, you actually understand genetics a whole lot better than you think you do. In fact, you might understand genetics better than a lot of biologists do. And there's a whole field called bioinformatics, which is about the overlap between computer science and genetics. And it's a huge field, and it's a growing field, and there's lots of people going into it. It's very hot. Genomics is a very hot field. Big data, which overlaps with marketing hugely, is also a huge thing in genomics. And so, like, guess what? If you have an engineering background, if you have a computer science background, what you really have is you have a liberal arts education for the technological side of the 21st century. And you can use those tools in all kinds of places. And all of a sudden, evolution started to make sense. And I started finding a bunch of things that a whole bunch of people don't want to talk about. Okay. The creationists don't want to talk about it. And people like Richard Dawkins and Jerry Coyne and the hardcore atheists, they don't want to talk about it either, because the truth is actually somewhere in the middle. It's not out at these extremes. It's not Bill Nye, the science guy. It's not Ken Ham. These guys are not giving you good science. I can prove to you that they're not giving good science. I can prove to you that they're feeding you an agenda that supports their philosophy and their conclusions. It's not science. It's not true. The kindest thing you can say about Bill Nye is everything he says is 10 to 30 years out of date. And that's the nicest thing you can say about it. And it actually, in Ken Ham, the younger creationists, they're in many ways just as bad. They're not as bad or worse, depending on your point of view. I'm really not sure how to come down on that, but I'm telling you, there's a whole story that most people have never heard, and it is fascinating.
Yeah, and it makes sense also, like, since you're talking about the motives and whatnot, like, and I think both of us could probably be in the same boat here. Is what is our motive? I mean, what you just defined, where you're kind of standing and where I feel like I'm standing too, is in a place where everybody hates you. And so that's not like, unless you have like, there's really not a monetary, I mean, books make money, but not a lot of money, right? I'm an author, you're an author, we both know this, right? Some people think that people make a lot of money, but it's really like, I can speak for myself. My motive is getting people to think and finding the truth. And that's, being on the side of picking a stance where everybody is likely to hate you and passionately is not a stance that you just pick unless, just, what I'm saying? So I think that's worth pointing out.
Well, John, the truth is really the 5% atheist zealots hate me and the 5% creationist zealots hate me. But if you live your life in the middle and you were never really quite sure that either one of those sides was really giving you the whole story, which a lot of people kind of at a gut level, they feel that way. They can't really articulate it. They don't know enough to defend it, but they just have a feeling like, there's something a little off about this whole conversation. You'll love this. You will absolutely love it. If you're a programmer, if you're a programmer, you're like, they're saying that accidental copying errors of DNA multiplied millions of times eventually create evolution. I've never seen that work in software. I've never seen that work in photocopies. I've never seen that work on USB sticks or websites or anywhere else. I mean, we have who knows how many gajillions of petabytes of data going back and forth across the internet, and it gets miscopied all the time. Nobody's ever seeing better software like come dripping out of some orifice somewhere. It's really interesting. Like, if random copying errors and natural selection was all you needed for evolution, then why does Bill Gates even need employees? Why doesn't he just get about 100,000 computer servers and just run corrupted versions of all his software all day long until occasionally a better and better version comes out, right? Because that's essentially what Richard Dawkins and Bill Nye and Jerry Coyne would have you to believe, that all you need is billiard balls banging around in the universe and survival of the fittest, and presto, everything gets better and better and better and better. And this is in textbooks, it's all over the place. But what I definitively figured out, it's not true. In fact, there's no evidence anywhere that anything evolves that way. Now, hear me out. I am not saying evolution doesn't happen. And that was the surprising part. So I got a certain distance into this, and it was like, Well, there's no way evolution happens by accident. Like it would have like random copying errors only destroy information. Copying errors are noise. Noise always destroys. Noise is always your enemy. I was in networking. I know this.
Right.
Networking, data storage, anything like that. If you corrupt a signal, it's garbage.
And
Okay.
yeah. Oh, I was going to say it's worth pointing out to the programmers who will understand this, which I thought was really good, is the layers, right? Because those the protocol,
Oh yeah.
right? Because
Yeah. And
that's, I mean, every programmer knows that that if you take some code and you change the bits, it totally corrupts it. It's not even like it has to be changed at the appropriate layer of the
right.
protocol, otherwise it's meaningless, right?
Right. So you can write a piece of code and you can change it in the editor, but after you compile it, like it's baked. Like you can't take compiled code and then like insert some copying errors and fix a problem. Like it's impossible. It'll never happen. And that's the problem with the Richard Dawkins version of evolution, is he's saying you can do that and you can't. It's, in fact, it violates something in communication called information entropy. But see, here's where it got interesting. What got interesting was I found out evolution is actually true anyway, and you can do evolutionary experiments in the lab, and you can create changes. A protozoan under stress can splice its DNA into 100,000 pieces, rearrange the pieces, and reconfigure its whole biochemistry in response to a stressful situation like nothing to eat, or it's in the presence of some kind of predators or chemicals or something like that. Absolutely amazing. There are certain things that you can do that in anywhere from 24 hours to 24 months will generate a brand new species that never existed before. And you can do this. And it's all because of those layers. So the genetic codes, just like Ethernet or any software stack, it's got layers too. This is why we have different things: chromosomes, genes, lines, signs, codons, start bits, stop bits. And so it's highly structured, and cells know how to modify the code. And this is the really amazing thing. And this goes back to 1944. A woman named Barbara McClintock was doing these experiments with corn. And at the time, it was very popular that people would take radiation. They would damage DNA with radiation, and they would do experiments to see what would happen with plants. Well, now, most of those radiation experiments were never created what all those people thought they would. They thought they could create mutations and create evolution, but they were actually operating on the wrong theory of evolution. They were operating on the same theory of evolution that most people still hear today, and it doesn't work. And most of those experiments didn't work. Barbara did something a little different. She approached it like a hacker, and you could say she threw the plant a curveball. She was working with corn plants, and the plant threw a curveball right back. And what the plant did was she damaged one of its chromosomes so it couldn't reproduce. And the plant repaired the chromosome by taking genetic material from another part, making something brand new, and then suddenly being able to reproduce again. And she figured out what happened. And it was like, oh my goodness, these plants are smart. They're actually modifying their own genetics. And she went to a symposium at Cold Spring Harbor in New York, and she presented to a bunch of her colleagues, and half of them laughed at her, and the other half were just mad. They're like, who does this woman think she is? Like, doesn't she know these genes are just beads on a string, and these plants aren't modifying their own chromosomes? What are you talking about? Well, I mean, they just kind of totally rejected this. Well, 30 years later, she won the Nobel Prize.
Wow. And
Okay.
no one hears about this.
No.
And that's what I think the example to that's it's the higher layer, right? Because I think what you said at first was like the random radiation, it didn't work because it was
Mm.
destroying things at the nucleic acid layer, right? The
Yes. Yes.
GATC layer, and that's like messing with the binary of a file.
Hmm.
And what she did was she took it up one layer higher in the protocol to the chromosome level, where it actually made, when you made changes, it made sense because it wasn't corrupting the data, and then the plant responded at that level, at the chromosome level, if I understand correctly.
Well, what she actually got the plant to do was reveal the layers.
Mm,
Okay,
okay.
so she just had a bunch of code and it's sitting there, and this, by the way, this is before Watson and Crick figured out DNA. And so they knew what chromosomes were, and they could look at them and they could see them, and they could do certain experiments and find certain things about them, but it was mostly a big mystery box. What happened when she started doing this is the plant is taking this section of code and moving it over to here, and this section of code and moving it over to here. They're called transposons,
Mm,
and this whole phenomenon is called transposition. And she started to break the whole thing down. She's like, okay, this section does this, this section does this, these things here, we call them jumping genes because they move all over the place, and we don't know how, why, or when, but I know that these jumping genes were actually used to repair this chromosome and make the thing able to reproduce when otherwise a plant was going to die. And it did it in real time. Like, she didn't have to do this with a million plants and wait a million years. It happened in real time. Okay. This is evolution in real time, which is how evolution actually occurs. And so this was really extraordinary. And so what happened was she was ignored for about 20 years, but then all these other researchers started running into this too. James
right.
Shapiro figured out in 1968 the bacteria can do this. And he's a professor right here at the University of Chicago. He's a very respected guy in the genetics field, and he's written a bunch of really important papers. And so this completely changes the entire texture of evolutionary theory. Okay, this doesn't happen by accident. Does not happen by copying errors, and it doesn't just happen by certain things die and certain things survive, and then the survive. I mean, it's so much richer than that. And when you really get into it, what you start to realize is what plants do, what animals do, what cells do. It's really very similar to what software programmers do. It's
Yeah.
very similar to what musicians do. It's similar to what artists and poets do, which is they have a collection, they have a tool belt, they have a set of tools, and like, hey, John, um, oh, play that riff for me again. And you're like, no, play it this other way. Why don't you play it in D flat instead of C sharp? And you're like, okay, and like,
Right.
okay, let's insert that into the mixtape,
Yeah.
right? And this is what's really going on genetically. And so it's way more interesting than anything Bill Nye is talking about. It's way more interesting than anything Ken Ham or the creationists are talking about, because this is something that I think software engineers could learn a lot
Yeah.
by studying, like a lot. Like, I think like there's 100 Nobel prizes hiding in this. I
Right.
think there are centuries of discoveries that we're barely scratching the surface of.
And I think it's interesting too, like that, what you're describing too. Like, I think on both sides of the equation, because I had studied creation science, like this literal 7 day, and then I had studied evolution, and on both sides, kind of the black sheep on that, the note that everyone kind of, I don't want to say that kind of throws both off is Gould when he says the punctuated equilibrium. And this
Right.
explains it. Now it's like, because when I was thinking with my evolution hat on, my Darwinian evolution, I was like, that punctuated equilibrium thing, like that's a really poor explanation. Like if that's how evolution, like that's how we explain away things, there's some holes there. And then from the
Why
creation,
don't you explain what that term means? Because I don't think most people know that term.
okay, so one of the things like with the fossil record was that, and correct me if I've got this wrong, but my understanding of it is that they found these problems. They said, okay, well, it looks like there's this Precambrian explosion, right? There's like all these points in the evolutionary tree where it's like all life suddenly exploded. Like evolution happened really rapidly, like from the fossil record. So it doesn't make sense. So Gould came up with this idea. He said, well, there's this thing called it's punctuated equilibrium, which basically like at certain times evolution increases. It happens at a more rapid clip, and
Right.
and the evolutionists of course kind of don't, it doesn't really fit in with the Darwinian model because there's no explanation. And the creationists, they jump all over it. They don't really like that idea either, because they're like, well, this is ridiculous. Like this
Right.
must prove 7-day creation, because how could you believe this ridiculous thing? And
Right.
so but now what you're saying, like, is now it's like, oh, okay, that actually makes, under environmental pressures, if evolution is not just this random mutation, like survival of the fittest, if that's not the process, but it's actual environmental pressures actually influence it, now it makes sense. Now the fossil record fits in with that model, and we don't have to come up with some ridiculous explanation.
Well, right. And all of us have experienced punctuated equilibrium all of our life. So for years and years, there's vinyl. Okay.
Mhm.
And then somebody comes out with cassette tapes, right? And then all of
Right.
a sudden you have that, right? And then somebody comes out with CDs and you have that. And so it's like you have vinyl and you have tapes and you have CDs, and then it'll stay, the technology will stay the same for a long time, and it'll have these little incremental improvements. Okay, so the cassette tapes get a little better, a little better, a little better, but there's nothing magical. Like it's just these slow improvements, right? And then all of a sudden you have CDs, and then all of a sudden you have MP3 players and stuff, right? And so we see this with technology all the time. Now what's actually going on is there's experiments going on constantly. Well, let's come up with something better than this. Let's come up with something better than this. But 9 times out of 10, they never really get anywhere. Oh, SACD comes out and the world doesn't really accept that, or mini disc comes out and the world doesn't really accept that, right? Or certain programming languages come along and they fall by the wayside. They be like Fortran, like nobody uses Fortran anymore,
Oh,
right?
you're gonna get comments on that.
Well, somebody does, but right, nobody I know.
How about Dart?
Um,
Google Dart. I think we can put that one on the chopping
right,
block. All right.
right, and so organisms are they're just like people. They're trying stuff,
Yeah.
okay? And so when you're taking antibiotics, the bacteria are trying stuff. Not only are they trying stuff, they're going and they're stealing DNA from other cells. They're like, hey, do you got anything interesting? I need a pump. Anybody around here got a pump? Oh, you got a pump? Okay, here. So send me a copy. Like all these cells, they have a Dropbox folder.
Right.
It's called a plasmid. Okay. And like they have one, like the plasmid, they hook up. Here, I'll send you some genetic material. It's an open source file sharing folder is what it is. Send you some material, and that bacteria goes, hey, there's a pump. I can use this. Inserts it into its genome, reads the code, builds a pump, pumps the poison out, updates its Dropbox folder, starts sharing code with all of the other bacteria friends, and then it starts dividing off bacteria that all have pumps and Dropbox folders. Okay. And guess what? All of a sudden, your antibiotic doesn't work anymore, and you're in serious, serious trouble. Right. And this is what happens if you don't finish your antibiotic.
Right. And I was just going to say, I think some people are going to say, well, that doesn't make sense, because you can't just take the pieces of the genetic code. And what you're talking about is doing it at that protocol again, that layer where it's like there's a start a start sequence and end sequence here. You're not
Yes.
taking, we're taking modules and we're dropping
Yes.
modules. We're recombining modules. We're not recombining random strings of GATC and, you know, in nucleotides.
Mm-mm.
Where they actually
No.
have a stop bit and a start bit, and this is a section, and we're rearranging these higher level pieces, not just random bits of code.
Yes, and this is described in my book Evolution 2.0. It's in the chapter on horizontal gene transfer. In fact, I have a little diagram, and it's like the genetics people call it a cassette. And it's like, okay, so here's a string of code, here's the start sequence, here's the end sequence, here's all the piece in the middle, and that bacterium, it's a strep germ or whatever kind of germ that it is, it's identifying that. It's going, okay, there it is, that's the one I want. Now, it's not clear how intentional this is. There's a whole bunch of this that is not clear. Okay.
Right.
But I can tell you this, as a communication engineer, I can sure as heck promise you it's not random, because random processes applied to code like this would never work. There is a whole level of mathematics going on here. There's a whole level of fractal reorganization that's going on. It is friggin' amazing.
Right.
Okay. And so a religious person should never be afraid of this information, because what it does is it makes the universes suddenly a whole bunch more amazing than you were ever told in high school.
Right.
Okay. So there's always somebody that goes, oh, that's no big deal. That just happened by accident. No. These kind of things don't happen by accident. But on the other hand, if you're a science lover and you're offended when people go, oh, God did it, so let's go out to lunch, let's have a 3 martini lunch because no scientist can ever answer this. If that kind of conversation offends you, well, I can relate. Like, a scientist's job is to figure out how things work. And what I am saying in Evolution 2.0 is there's so many more layers to discover about how this works. The scientist's job is never going to end. I mean, any honest scientist should love this book, because this book opens the door to billions of dollars of research that nobody's done yet. Okay. Nobody who understands this should have any trouble getting a grant from any honest grant committee, because there are so many things to discover. And so I really, as this whole project evolved, I really became, I started to see that this war between science and religion, it was shutting down science, it was shutting down curiosity, it was giving people glib answers that don't make any sense. It was empowering people like Bill Nye and Richard Dawkins to get away with glib, ridiculously oversimplified answers that don't actually solve any problems at all. They do not further science. Richard Dawkins is not a friend of the scientific process. Bill Nye is not a friend of the real scientific process. I know you think he is. I know he's on TV. And having said that, you know, neither is Ken Ham, neither is Answers in Genesis, neither is the Institute of Creation Research. They're not helping. Okay, so it's sort of like, okay, have you ever heard of a situation where you didn't like either the Democratic candidate or the Republican candidate?
I've never heard of that.
It's
that, like Columbia?
It's like, you know what? In science, there's more than 2 choices.
Yeah.
In politics, you might end up having to vote for one or the other, and not vote at all. But in science, there's always more options. And
here,
that's the good news.
I got an option for you. Let's go with the Arnold option here. But yeah, no, what you're saying makes a lot of sense, and that's what really convinced me. Is, like I said, I had done the research. I know a lot of people when I made the first video, they're like, "Oh, John, you're just an idiot. Like, how can you believe anything on the creation science?" But even Ken Ham's stuff, like they're at the surface level, they're decent arguments. I think most people haven't even read that, right? And it's like, but there's holes, there's mistakes, there's problems. And then when I read through, Dawkins stuff, it was the same thing. I was like, there's holes, there's stuff there.
Right.
There's strong arguments on both sides, and there's weak arguments on both sides, but none of them have evidence.
Okay, and to their credit, okay, let me be very clear. Richard Dawkins' work has a lot of true statements and a lot of valid observations.
Right.
But there's a whole bunch of stuff he's not telling you. Okay. And the same thing's true on the other side. I mean, actually, some of the creationist literature is actually quite useful. And what I had to do, I had to go through all of it and say, you know what? I'm willing to take this whole thing apart. I'm willing to disassemble an entire car engine just to find one good cylinder. Okay.
Right. Exactly.
All right. I mean, I will read through a whole entire book, and I might think that 8 out of 10 chapters are crap, but if 2 of them are good, and if the guy says something that it's true, then I'm going to accept it. And I don't care who he is. I don't care if I hate his guts. Okay. I don't care if I hate his politics. I don't care if I hate his religious views. If he says it's true and it can be verified, then I'm going to put it on that Post-it note and stick it on the wall. Like, okay, add another verifiable fact to the list. Okay. And so it was like the Darwinists were right about a bunch of stuff, but they had this big blind spot. The creationists were also right about a bunch of stuff, and they had this big blind spot. And of course, all these guys, they're totally talking past each other, right? They're calling each other names. They're acting like they're 6 years old. They're descending into this just juvenile behavior and name calling and snarkiness and everything like that. And, frankly, as soon as people descend into that, I switch off. Like their whole credibility just goes away, right? I have no patience for people that want to sit and call other people names. If that's all you can do, you obviously don't have anything to bring to this argument, and I am not interested in your opinion, right? And so I got past the popular literature, and pretty soon I'm reading scientific papers.
Yep.
And there is so much stuff, I am so glad I finished my electrical engineering degree and I became scientifically literate so that I could read scientific literature. Like, if you have a science degree, you can figure this stuff out. And I waded through it. It was like, wow, like, why is nobody talking about this? How come Barbara McClintock isn't in every textbook? Because she really should be. Okay. Right. Another one, Lynn Margulis. Actually, Lynn Margulis and a bunch of Russians from 100 years ago, okay, they figured out this thing called the theory of symbiogenesis. And this is really fascinating, okay? So a business version of symbiogenesis is a Starbucks inside the lobby of a Marriott hotel.
Right.
Okay.
Yeah.
It's okay. Symbio, Starbucks and Marriott. So the Starbucks makes the Marriott more valuable. The Marriott makes the Starbucks more valuable. Both of them bring more people in, makes everybody happier, makes more profit. Well, the first merger acquisition in history, or one of the big ones in history, was when a blue-green algae and what is now known as a plant cell merged, and instead of the plant cell eating the algae made a home inside of it. And that is the reason for every single green grass or leaf or plant that you've ever seen in your life.
Right.
Because what they don't tell you in high school science is that a chloroplast which everybody learned about chloroplasts. They make chlorophyll, they make things green. A chloroplast is a blue-green algae. That's what it is.
So
It's
you're
got its
saying its own DNA, right?
it's got its own DNA. It reproduces on its own cycle. It lives inside the plant cell, and they're in this exchange. It's like, okay, I'll give you a safe home, and you give me this energy that you get from sunlight and carbon dioxide
Yeah.
or oxygen. Well, when the whole process of okay, so sorry, plants consume carbon dioxide
Right.
and produce energy from sunlight, right? So it's actually a blue-green algae that does that. Okay. So similarly, everybody's heard of mitochondria. Most people don't quite exactly know what it is. A mitochondria is a part of your cells in your body that converts oxygen to energy.
Right.
Okay. It's the energy plant in your cells. Okay. Well, it's the animal equivalent of a chloroplast. And it's also a symbiotic bacteria living inside your cells that has its own DNA. And the DNA is largely identical to the DNA in other free bacteria. It's a merger acquisition. It's a Starbucks inside a Marriott. And the Russians actually started figuring this out in the late 1800s. And by the 1930s, it had become a major branch of science in Russia. But then communism and Stalin and all this kind of stuff happened and all kind of got buried. Lynn Margulis resurrected it in the 1960s, and nobody would publish her papers. And they were like, oh, get out of here. This is crazy. She's like, no, evolution proceeds in leaps and bounds. It's this punctuated equilibrium thing again. And she's
Yeah.
saying, look, lichen is algae plus fungus. And like there's all of these different merger acquisitions in history, and all of a sudden, bam, now we have a plant cell that produces chlorophyll. And so I think her paper got rejected by 15 different scientific journals before she finally got somebody to accept it. And this was the old school Darwinists fighting progress.
Right.
And they have been fighting progress for 70 years. Okay, it is time for this thing to be over. Neo-Darwinism is dead. This whole idea that y'all read in textbooks that all you need is random copying errors, billiard balls banging around the universe, natural selection, and you're going to get evolution, that is total BS. Nothing works that way. If that were true, Bill Gates wouldn't need staff. He wouldn't need payroll. He'd just need 1 million computers and somebody to feed the garbage into the input and produce the joules at the output. It doesn't work that way. And so actually cells are smarter than we are. They know how to do things we don't know how to do, and it's time for us to start learning.
I think it's interesting that you said that about like how we need to close the book on the subject or that, because I think a lot of the evolution, at least the response that I saw whenever you say anything against the standard, what CNN says published model of evolution or textbook model, is they say, hey, look, we just need to stop. We already got this figured out. We're already done with it. We need to stop having these arguments. Like, if you don't believe in evolution and you don't believe in the Darwinian evolution, you're just a dummy. You're just stupid. You're just religious. And like, we shouldn't even have these arguments anymore. And my answer to that is always read On Liberty, because you need to understand why it's important we don't just label things and say we're done with it. You always need to re-examine it and have an argument. But it's amazing that like, what you're saying makes sense. It's like we got to stop doing that. We need to re-examine these things. We can't just take these things for granted and just say we're done, especially when we don't know, unless you can produce the actual mechanism of exactly how something happens, you're not done. You always have to re-examine the model, always have to revamp the model, always have to question those assumptions. And so many people, like, I feel like in society today, not just in science, but even in politics and all kinds of areas, they've shut their mind and they're just saying, nope, we've already got it figured out, and I'm going to have this snarky attitude if you disagree with me because, hey, Neil Tyson or Bill Nye says this, or and
Right.
and who are you to question Bill Nye? I mean,
Oh, right. Well, and so here's the smoking gun. Okay, so if you are a evolution doubter, I understand, because I was very skeptical too. It's like, this doesn't make any sense. So read my book, Evolution 2.0. If you're an evolution doubter,
right,
this won't only change your mind. It really probably will change your mind about evolution, but it'll actually change how you feel about evolution, because it ceases to be this stick that atheists beat religious people over the head with. Okay. In fact, it kind of gets turned around and it becomes a stick. Like, if you want to beat atheists over the head, evolution becomes your new club. Now, if you're a Darwinist, or if you're like a Richard Dawkins fan or something like that, and you're like, I don't know, I think this sounds like a bunch of BS. I don't believe this. Here's what I want you to do. I've got a blog post called Memo to Richard Dawkins, Bill Nye, Jerry Coyne, and PZ Myers. Recess is over. Just go to cosmicfingerprints.com and search Recess is over. And what I do in that blog, in a very, I don't know, 1,000 words, I show you that those guys' books are 10 to 30 years out of date. And I show you exactly how you can find out, you can prove to yourself. All you got to do is take a list of words: transposition, symbiogenesis, horizontal gene transfer, epigenetics, hybridization, those are what I call the Swiss Army knife blades of evolution. Those are the basic tool belts of the evolutionary process. Go search their books and see if you even find them talking about this stuff at all. Because for the most part, you don't. They say virtually nothing. Then go to Google Scholar and type those things in and see that for the last 10, 15, 20 years, thousands and thousands and thousands of papers. For any biologist that's listening to this and is up to date on the research will know that I am telling the truth. Okay. Now, in fact, next week I'm going to London. And the reason I'm going to London is that the Royal Society is holding a meeting called New Perspectives on Evolutionary Theory. Now, I can't tell you like what's the conclusion or the outcome of this meeting going to go on. I couldn't predict that before actually going, but I can tell you this. Evolutionary theory is in a massive, massive change state right now. And there is a whole set of models. Extended evolutionary synthesis is sometimes called the postmodern synthesis, sometimes called third way. There's a whole branch called systems biology. And all of these different versions are basically saying the old Darwinian model doesn't work. It doesn't explain all of these things. It's beleaguered with problems. We need other models. We need other explanations. And there's lots of scientists that are working on them. The only problem is the news has not reached the general public. This is not going to be a surprise to anybody in 5 years, but it's new now. And I want people to know, because if we could take those crazy 5% zealots from the extreme left and the extreme right out of the conversation and replace it with real science, real observations, real experiments, real Nobel Prizes, real genomics, real big data, real results, real medicine, then the whole thing changes, and it's very exciting. And as you read my book, as you read about the stuff, you're going to find that whatever you do for a living, it's going to start sparking ideas. You're going to be like, hey, wait a minute. Hey, wait a minute. This could work other places. I can use this.
Right. And that's a great, that's a great way to kind of suss out truths, I think, because principles are universal and they always
Yes.
apply across every discipline. When you think about the
Yes.
principles of sowing and reaping, when you think about like the people that live their lives based on principles,
Yes.
those people are successful wherever they approach it. I mean, you could even look at like someone like Elon Musk, and you could see some of the principles, and he's talked about some of the principles he lives by, and that's why he's so dang successful, is because those things they span the universe.
Exactly. And when I went on this search, I said, there has got to be a principle that says how this stuff actually works. Like, I don't think randomness is a principle that I can rely on here. What is really going on? And I did. And the Swiss Army knife is the term I use for it. Like, yes, biology really does have a set of principles that it uses, and they're ingenious, they're cooperative, they're collaborative. And so if you always felt like this whole evolution conversation didn't quite jive with your common sense, try this out. I think you'll really love it.
Okay. Well, thank you, Perry. I know we got to wrap up here. I wanted to ask you one more question that I've been dying to ask you from this interview. If you don't mind, give me a couple more minutes here.
Sure.
It is, and it's related to the kind of the mindset I think that people have. I just want to get your take on this and just why you think that we do this and what's influenced us from the academic standpoint. But I'm going to pick on one particular thing here, which I've always had a problem with. I know a lot of people don't like my viewpoint on this, which is dark matter and dark energy. I feel like it's kind of a ridiculous explanation that we've come up with for not being able to for a theory that we have about how the universe supposed to work, and we can't detect anything, so we must say that this is undetectable matter. Now, don't get me wrong, dark energy and dark matter could very well be true, but I feel like that's the same. This is the thing. This is where we're at. I feel like academically, and I think, and I'm drawing a parallel because I think it's the same thing with the evolution standpoint. Is it's like we just accept all of these things that for fact, whereas if an alien came and looked at with these theories we have and how we explain them, they wouldn't draw those same conclusions. They'd be like, that's weird, you just kind of made that up because you didn't know what was really happening. But like so many smart people, intelligent people just like hold this which such they're so tightly bound to this. Why does this exist like this in the academic community today? Why have we gotten to that point?
It's really funny you bring that up, John, because first of all, I'm not an expert on that, and I haven't researched this enough to give you an opinion. I'll just give you a couple of touch points, okay?
Okay.
So dark energy and dark matter are mathematical constructs that have been put together to make things work. And as an electrical engineer, electrical engineering is very mathematical. I can appreciate that because, like, somebody had to come up with imaginary numbers to make that work, and it turned out to work.
Right.
It's like, well, imaginary numbers are actually real, okay. And so they could be right. Okay. On the other hand, I was just listening to an interview with John Hands, who wrote a book. It came about the same time mine did. It was called Cosmo Sapiens. And John and I did not have any contact with each other whatsoever. We were completely independently. And if you like this kind of stuff, if you like these kind of questions, you should go to Amazon and buy Cosmo Sapiens now. You'll love it. Okay. John like this is a 700-page book that tackles everything. Okay. In
All
fact,
right.
he's got 3 or 4 chapters on Darwinian evolution, and he comes to the exact same conclusion I did.
Wow. Okay.
Okay.
I'm interested.
And you should interview him, John,
Okay.
because he's brilliant. He's from the UK. He's a British guy, very scholarly. Oh my goodness. Like what a piece of scholarship this book is. Now, what he does in his book is he's like all these really big questions. He like puts them on the anvil and he starts hammering them. It's like,
Yeah.
what is going on here? What is this all about? What about consciousness? Where did matter come from? Where did humans come from? You know, where's this all going? And what he says, so he gets into biology and he gets all these snarky college professors like, how dare you question? Okay. And again, he eventually comes to very similar conclusions as me. It's really spooky how similar
Yeah.
the paths are. Okay. So you can, and again, knowing that we never talk to each other, I think you'll love to see that. Well, then he gets into cosmology. And what he figures out is that none of this stuff is nearly as solid or nailed down as everybody thinks it is. And he raises the exact same question. He's like, well, you haven't touched the dark matter and you haven't seen the dark matter and you haven't put it on a scale. And it's really actually just a mathematical construct. And so it's like, you know, it's like he lifts the skirt of modern science and he finds cellulite and varicose veins and like all of this stuff, right? And as you look at the whole thing, you start to figure out, you know what? You really have to be very careful not to confuse what a scientist tells you with fact.
Right.
And in fact, think about it, John, true or false? If we look at the last 500 years, true or false, 90% of scientific theories have ended up being wrong. True or
Absolutely
false?
true. We constantly revise models. I mean, ask an elementary student what to draw an atom for you, and what are they going to draw? They're going to draw the little, you know, the dot with the circles. That's not even the correct model anymore, right? And all the models are flawed. We constantly revise models. And that's all that science is models. And but CNN has to give you, I pick on CNN, but you know, textbooks, whatever, they have to give you a soundbite. They have to give you a condensed, the layman version, and they paired it as fact. They say in a matter of fact way, the Earth is 5 billion years old or whatever. They used to say, I mean, 10 years ago, it used to say we think, or by best estimates, but now it's like all of these things, they're just being fed to people as if this is absolutely fact. We know this is true. This is the foundation and we need to build on top of this. And so people stop questioning this stuff.
Yes. And so what I would say to people is you need to be really careful not to let things that you think are facts become dogmas that you blindly defend when you yourself don't actually know how many problems there are.
Right.
Okay. You have to be, you know, popular level books you have to take with a grain of salt. Okay. Yep. And questions are always more valuable than answers.
Yes.
Okay. And the real art of life is learning to ask questions and go hunting for answers and ask better and better questions so that you get better and better answers. And I think in your life, if you ask the right questions, it's kind of like the scientific method. It's always eventually going to lead you in the right direction. You know, the scientific method is really reliable. Okay?
Right.
The method works, but don't confuse the method with the conclusions that they happen to have right now. You got to remember, scientists are people and they have careers, they have egos, they have grants, they have departments, they have overhead, they have bureaucracy, you know, and so they're not, it's not like scientists are some, elite tribe of Illuminati who like
Right.
know more than the rest of us. Okay. And the really good ones are humble.
Yeah.
And the better a scientist is, the more readily they will tell you, I don't know, we don't know, I don't know, we don't know. If you think science is a place where you're going to scratch your itch and your desire to get perfect, exact answers, you are sooner or later going to be very, very disappointed. And it
Yeah.
might not be today, but it'll be someday. You just please be very careful. Meanwhile, I love science. I'm sure there's problems with some of the electrical engineering models that I've grown up with, but I know I can build an amplifier and it works. Like, well, so that's a certain amount of certainty.
Right.
And in any evolutionary theory, ought to give you stuff that works. And that was my criteria. It was like, I'm going to put on my engineering hat and I'm going to see where it goes. And man, was it ever fascinating.
And those models work for the time, like you said, like with the
Yeah.
electrical engineering one. That's not even a perfect model, even though it works. I
Right,
mean, a
right.
lot of people argue to me. They say, "Well, we landed a probe on Mars, like with a parachute and all that." I'm like, "Yeah, but when we try and land it, when we try to land a micro machine on an ant on Mars, or a dust particle, a specific rock on Mars, we're going to need a different model. That model works really, really good. But if you went to the subatomic level and tried to do something like that,
Yeah.
we have no idea how to do it because that model is not truth. People confuse truth with models, and it's just yeah. So I'm glad you said that, and I'm really glad that you said about when you talk to real scientists, they say I don't know a lot because
Yes, they do.
I
Yes,
feel like
they
we're such
do.
an arrogant species that we feel like we have to know all the answers, and we don't. And it's okay to not know. And the smartest people realize that. I
Yeah.
think.
So celebrate the inquiry and go on the adventure and be content with can you embrace mystery? Can you actually learn to love the mystery? Can you actually live in the middle of mystery? And like what if you run into questions that you bang away at for 25 years before you ever get an answer? Is that okay? I sure
Right.
hope so. Your life will be a lot more fun if
Yeah.
you're okay with that.
Yeah. You don't have to have an opinion on every single possible thing.
People can get 3 free chapters of Evolution 2.0 at cosmicfingerprints.com, and the book's for sale on Amazon. And I just really want to encourage you, don't take my word for anything, but ignore no verifiable facts.
Awesome. All right. Well, thank you, Perry. I really appreciate it. This has been super fun. For those of you, like I said, Perry's been someone who I felt has been a mentor. I've read a lot of his books, not just the Evolution 2.0. Definitely check it out. I'll put a link here. There'll be links to everything that's mentioned here, as well as check out if you're interested in marketing. I know some of you are entrepreneurs, and he is like the source. Really, he applies the same kind of engineering rigor and to the field of marketing. And some of you, if you wonder like why does my sales page look like it does, or the opt-ins and all of that stuff, a lot of this comes from his Perry has helped me to build a business out of Simple Programmer that actually makes money.
That's
So
good. Thank you.
I appreciate that,
Congratulations.
Perry.
That's great. Well, thanks for having me on your show. It's been really fun. And if you know some other shows I should be on, shoot me an email or put me in touch with some people. And I just want to encourage everybody listening, be curious and embrace the mystery.
All right, take care. Thank you, Perry.
Take care.